Hi everyone, and we're gonna do another exam question today. The question reads as John has an empty box. He puts some red counters and blue counters in the box. The ratio of red to blue counters is 1 to 4. Linda randomly takes two counters from the box. The probability she takes two red counters is 6 over 155. How many red counters did John put into the box? Okay, let's try and attempt this question. See if we can solve this. Alright. So the first thing I want to start off with is the ratio of red counters to blue counters. That's 1 to 4. That's telling me what ratio it's in. It doesn't tell me that. So I know that in total there are 5 different parts. I don't know how many counters each part represents. So what I'm going to do is the ratio of, right, we can use the colors here. So ratio of red to blue. Let me change the color again. Right, red to blue. Let's do that. Okay, so instead of writing it as 1 to 4, I'm going to write it as, okay, x to 4x. Okay, so altogether I know I have x plus 5x, sorry, x plus 4x, that gives me 5x. So 5x is the total number of parts. That x is like 1x. So for those of you who are confused, where did he get the x from? So instead of writing it as 1 to 4, I wrote 1x to 4x. So 1 times x represents the red counters, and 4 times x represents the blue counters. Okay, now the question says the probability that she takes 2 red counters is 6 out of 155. So if she took the first red, so let's do probability of red. Should have done this in red, but there we go, we're doing it in yellow. Probability of red and red. When she takes the first red counter, the probability of her getting 1 red counter would be x, or 1x over 5x. That's the first red counter, because there is 1x or x red counters out of 5x counters. Now for Linda then to take the second counter, which is red, I would have to do, now there's 1 less red counter than there was before, so the number of red counters is x minus 1, and inside the bag, inside the box, there's 1 less counter because she's already taken 1 counter, so there'll be 5x minus 1 counters. Okay, so we've got this situation here. What I'm going to do is I'm going to put a bracket over here, and I'm going to try and expand this. Okay, and we know that the probability of getting a red and a red, or 2 reds, is 6 over 155. So we do 6 over 155 is equal to, and I'm going to expand this, x times x is going to give me x squared, and then x times minus 1 is minus x, all of it divided by 5x times 5x is 25x squared, and 5x times minus 1 is minus 5x. Okay, I'm going to need a lot of space for this one, so what I'm going to do is I'm going to clear out the question. So give me a minute please, because I believe if I go on the next page it stops recording, and I don't want to stop recording at this moment in time. So bear with me for a minute please. we shall continue. Alright. Okay, so at this point I'm going to cross multiply. So when I cross multiply, this denominator here, I'll multiply with this numerator, and this denominator I'm going to multiply with this numerator. So let's try that out. So I'll have 6 times 25x squared minus 5x is equal to 155 times x squared minus x. Okay, just a quick note, we can only cross multiply if I have one fraction on this side on its own, and on the other side I just have another fraction on its own. So this fraction doesn't add or subtract anything, and this whole fraction here does not add or subtract anything. That's the only time when I can cross multiply. Okay, and what I'm going to do is I'm going to expand this bracket. So 6 times 25 I believe is 150, so 150 x squared minus 30x is equal to 155 x squared minus 155x. At this point I'm going to try and get all the everything to one side. The way I make my decision is I look at the coefficient of x squared. So the coefficient of x squared over here is 155. The coefficient of x squared over here is 150. And I get rid of the smaller of the two coefficients. So I'm gonna get rid of 150x squared. So I'm gonna subtract 150 x squared both sides. And what that does is leaves me with just minus 30x here is equal to 5x squared minus 155x. And I'm going to get rid of this bottom bit here because I need all of that space as well. Here you go, and okay, and then I'm going to add 30x both sides. So on this side I'm going to be left with 0, and I'm going to have 5x squared minus 125x. What I'm going to do now is I'm going to factorize this. So I'm going to have 5x, open brackets, then I'm going to have x minus 25. So when these two multiply, 5x multiplies by x minus 25 to give you 0. So you can have either 5x equals 0. If you divide both sides by 5, you get x equals 0. But the problem is you cannot have 0 counters, so this solution would be incorrect. Okay, the other possible option is x minus 25 equals 0, and then you gotta add 25 both sides. So x would be 25. Okay, so x was one second, x was the number of red counters, and we've got 25 red counters. And just to check, so if she had 25 red counters, she would, sorry, if John had put in 25 red counters into the box, then the number of blue counters would be 4x. So 4x would be 4 times 25, which is 100. Okay, so the probability, this, let's do the check in blue, right? So the next thing I'm doing is I'm just checking if I get my answer right, if I've got my answer right. So in total there's 125 counters. 100 of them are blue and 25 of them are red. Okay, so in order to do my I'm gonna do the check in blue as I told you. So to get 2 red counters, you would have 25 over 125 times 24 over 124. Okay, and we could simplify these two. That's 1 over 5 okay, and these two, I know they come in the 4 times table, so I could divide them by 4. That'll give me 6 over 32. Sorry, not 32, 6 over 31. And then I can multiply this, so 1 over 5 times 6 over 31, that's the same as 6 over 155, which is what the question stated initially. If you rewind back the video, it says the 2 red counters, the probability of taking 2 red counters for Linda was 6 over 155, and I get that now, so I know that my answer is correct. So this bubble bit is my check. Just write check over there, and I can leave my exam knowing that I've got this question right. Okay, it's a pretty long video, it's a pretty long question as well. Hopefully did make some sense and helps everyone understand. Hope this helps. Take care.